Hello, my name is Agnieszka Gunia-Krzyżak. I work at the Department of Experimental Dermatology and Cosmetology at the Faculty of Pharmacy, Jagiellonian University Medical College in Kraków, Poland. I would like to present you today a topic entitled Photocytotoxic Potential of Selected Topically Applied Cosmetic Ingredients. This topic is a part of the research we conduct at our department. We mostly deal with cosmetic ingredients. We assess their activity and potential utilization in cosmetic products in terms of the activity. Additionally, we conduct a lot of research which are intended to assess the safety of cosmetic product ingredients as well as ready-to-use cosmetic products. Why do we do this? Actually, safety of cosmetic products is a very important issue. And some people even think that safety is more important than efficacy of cosmetic products. I wouldn't go that far, but definitely safety of cosmetic products is at least equally important as efficacy. Safety of every cosmetic product is assessed by a safety assessor, and there are many required safety evaluations of cosmetic products before they can be released onto the market. One of the important issues of safety evaluation of cosmetic products is evaluation of phototoxicity. Why is it important? Just think about an application of cosmetic product. Of course, we typically apply it topically and may directly go outside and provide exposure to the sunlight. In this situation, the chemical structures of photounstable molecules may change. Upon UV exposure, several photoproducts may arise, which may have unexpected influence on the organism. The certain cosmetic ingredient may lose its efficacy, and the photoproducts may be even dangerous. They can cause some side effects. The classical example of cosmetic ingredients which may go photodegradation are UV filters, because they are used intendedly to be exposed to UV radiation. They are routinely divided into organic and inorganic UV filters, while organic UV filters possess chromophores and auxochromes. They are used in cosmetic products exclusively or mainly to protect the skin and/or hair against certain UV radiation by absorbing, reflecting, or scattering UV radiation. Their utilization in cosmetic products is strictly regulated. For example, in the European Union, all authorized UV filters are substances in the positive list of Annex 6 to the Cosmetics Regulations 1223. The formal requirements say that following exposure to radiation, the active ingredients of photoprotective formulation should remain unchanged to the greatest possible extent to provide adequate photoprotection for consumers. However, after topical administration upon UV exposure, photodegradation may lead to a reduction or even complete loss of their photoprotective efficacy. Moreover, their degradation products come into direct contact with the skin, where they may contribute to phototoxic, photoirritant, and photoallergic effects. These degradation products may also act as photooxidants. The reduced photoprotection results in higher risk of skin damage, including burns, photoaging, and skin cancer. That's why the assessment of photostability in case of UV filters in cosmetic products is crucial and required for all of them. Additionally, photostability studies are performed for ready-to-use sunscreen formulations. In case of unstable UV filters, other ingredients of cosmetic formulation must be present to ensure proper photoprotective properties. The other examples of cosmetic ingredients which aren't photostable are retinoids, which at the same time are very popular cosmetic ingredients. They are mostly used in anti-aging formulations because their molecular mechanisms of action include enhanced cell turnover and renewal, stimulation of extracellular matrix synthesis, and anti-photoaging and antioxidant support. They are also known to regulate sebum excretion and to act as anti-acne agents. They also improve skin tone and barrier function. But their chemical structures clearly indicate that they are not photostable because they possess chromophores. And of course, not only the structure suggests that, but it was also proved in several research. Retinoids are prone to photochemical reactions, which include photoisomerization, photopolymerization, photooxidation, and photodegradation. Several studies showed that some excited retinoid species formed after photoirradiation may possess toxic effect on the skin tissues, both directly by toxic photoproducts as well as indirectly by production of reactive oxygen species. And also, it was shown in the research that UV radiation may alter retinoid-induced gene expression. So actually, taking together these facts, the treatment of photoaged skin may actually cause potential misinterpretation of the role of retinoids as agents protecting against UV radiation. This may potentially lead to their inappropriate use during sun exposure or tanning, causing toxic events to skin cells. In fact, retinoids are contraindicated during sun exposure, and UV filters must be used during topical retinoid therapy. In our research, we performed several studies in the area of photostability and phototoxicity of selected cosmetic ingredients. So far, we did not focus on identification of certain photoproducts, but we rather performed tests in the cell cultures and in the model of reconstructed human epidermis, which were subjected to UV radiation, and we checked the photo effects of the tested compounds. We used, among others, the well-validated model of in vitro 3T3 Neutral Red Uptake assay according to OECD test guideline number 432. In this assay, we performed appropriate culture of mice fibroblasts recommended in the assay. Then we seeded the cells in the multi-well plates, and the compounds were added after washing the cells. And the plates were incubated with the test compound for 1 hour. Then the plates were irradiated with a specific dose of ultraviolet. The dose was set as a non-phototoxic level of 5 joule per square centimeter, and we also, of course, used some dark control plates. After irradiation, the wells were washed and further incubated overnight with cell medium. After overnight incubation, the neutral red uptake assay was performed. We observed the changes in the color of the reagent corresponding with the levels of living cells. And finally, we measured the absorbance. Our positive control was chlorpromazine hydrochloride, and experiments were performed in 6 independent replicates. As a result, we calculated mean photo effect with specialized computer program. In this assay, we tested, among others, formetoxichalcone, which is indexed in a cosmetic database as an antioxidant, bleaching, and skin conditioning cosmetic ingredient. It belonged to a wide group of halcone derivatives, which were proved to possess a broad pharmacological profile, and they were shown to possess an anti-proliferative and cytotoxic effect on several car cell lines, as well as antimicrobial, antiparasite, antioxidant, UV protective, and depigmenting properties. We tested formetoxichalcone in a melanogenesis inhibition assay in B16F10 mice telanoma cell line. We confirmed that this compound inhibited alpha melanocyte stimulating hormone-induced melanogenesis, as well as 3-isobutyl-1-methylxanthine-induced melanogenesis. So the biological results were in fact promising. However, based on the structure of this compound, one might expect that it will possess also some phototoxic effect. And in fact, we discovered that for methoxychalcone was phototoxic with its mean photo effect of 0.5, which was similar to that of our positive control chlorpromazine. Although we couldn't calculate IC50 for non-irradiated cells, but irradiation resulted in a very low value of IC50, which means that the compound was much more cytotoxic upon irradiation. I would like to also show you another example, which is the amide derivative of cinnamic acid. This compound is our candidate cosmetic depigmenting ingredient, which was tested in several in vitro biological assays, such as inhibition of mushroom tyrosinase, inhibition of tyrosinase and melanogenesis in B16F mice cell line, but also it was tested in a pigmented reconstructed human epidermis and proved to be a promising depigmenting cosmetic ingredient because it sufficiently inhibited melanogenesis. And also the result of phototoxicity test were encouraging, were positive. I mean the compound wasn't phototoxic. The MPE was only 0.08 and actually we couldn't calculate IC50s both for non-irradiated and irradiated cells. Additionally, we used this compound in a cosmetic formulation in a model of reconstructed human epidermis in which the cell viability didn't change after UV exposure. The other cosmetic ingredient which I would like to present is curcumin, which seems nowadays extremely popular. It might be also considered as cinnamic acid derivative and more precisely as a ferulic acid derivative with hydroxyl and methoxyl groups substituted into phenyl rings. It is frequently used in dietary supplements and also becomes more and more popular in cosmetic products. It is also the ingredient of popular spice turmeric. But as soon as it is used as a spice, we don't use it too much. But when we apply curcumin topically and then go outside to the sun, it may cause many phototoxic reactions. So it could be used sometimes in a very irresponsible way. It has been actually well recognized as a natural photosensitizer and it is used in photodynamic therapy in cancer. It means that many experiments were performed in which curcumin was proved to be very cytotoxic upon irradiation. So the question may arise, do we really want to use it in cosmetic formulations? Of course, it is also known to possess anti-inflammatory, anti-proliferative, anti-tumor, antimicrobial, and immunomodulatory properties. And it is also indexed in cosmetic database as antioxidant and colorant cosmetic ingredient. And also, it is extremely popular, as I said, in dietary supplements for the prevention and adjunctive treatment of neurodegenerative, cardiovascular, and cerebrovascular diseases. But just try to remember that it is used in photodynamic therapy, so it may cause the toxic effect after topical application. And we tested that. We used curcumin in 3 exemplary cell lines, in malignant melanoma cell line A375, in cutaneous squamous cell carcinoma cell line A431, and in normal human keratinocyte cell line HACAD. As you can see, irradiation at certain doses of UVA and visible light caused dramatical decrease in IC50s, which confirmed phototoxic potential of curcumin. In these experiments here, we irradiated the cells together with the compound, and these conditions actually simulated the usage of curcumin in cosmetic formulation because we basically apply the cosmetic and then go outside. And this can be actually a little bit or even more than a little bit dangerous in case of curcumin. Moreover, we performed some experiments which we called irradiation without compound, in which we performed incubation for 2 hours, 4, 6 as well as 24 hours in the same cell lines. And then the compound was washed away, then the cells were irradiated and IC50s were calculated after 24 hours recovery time. And again, we observed significant drop in IC50s in almost all experimental conditions. We confirmed that curcumin is able to penetrate inside the cells and is able to cause phototoxic effect. And this raises the questions which we frequently ask us at our laboratory. Is natural a synonym of safe? Consumers tend to think that this is actually true, that everything which is natural is safe. Moreover, companies advertise their products as safe based on the natural origin of its ingredients. But our results are only a tiny example that actually natural is not a synonym of safe, and even natural compounds may be dangerous, of course, upon certain conditions. The conditions we choose in our evaluation were UV irradiations, in which formulations and certain cosmetic ingredients become toxic to cells. We plan further studies to characterize deformed photoproducts in our studies. Please find references used as a background of my presentation. The list also includes our articles. Last but not least, I would like to thank my collaborators, as well as I would like to thank you for your attention.